Hi students, now we are going to explain displacement vector by considering a particle's motion from an initial point to a final point. Now in the one-dimensional motion, how did we define displacement? Yes, it is defined as the shortest distance between the initial point and the final point. Now, how we are going to define displacement vector in two-dimensional motion is slightly different from that. For that, let us consider a particle is moving from an initial point A to a final point B. So, the position vector of the particle, I am going to consider the position vector of the particle at A with reference to the origin. So, I join O and A. Similarly, the position vector of the particle at the final position B. So, for that I am going to join O and B. So, in this picture, the vector OA, which is denoted by R1 vector. Vector OA is equal to vector R1, that is the position vector of the particle when it was initially at A. And OB vector, the vector OB, which is also represented by R2 vector, that is the position vector of the particle when it is at the final position B. So particle has moved from an initial point A at a time T1 it was at A. Then after a time, certain time at T2 for example, the position of the particle has changed to B. So that the position vector R2 is equal to the vector OB. Now, the coordinates of the particle at A are taken as x1, y1, and the coordinates of the particle at B are taken as x2, y2. So, these are the x and y coordinates of the initial point A at a time t1 and the final point B at a time t2 respectively. Now, what do you mean by displacement here? Displacement is the shortest distance between the initial point A to the final point B. So I am going to join A and B. So the initial position is A, the final position is B, and hence this vector AB. Can you see that this vector AB? Okay, this vector AB only is called the displacement vector, which is denoted by delta R vector. Delta R vector. So here the displacement vector is the vector between the initial position A and the final position B of the particle. Okay, now we are going to derive an expression for this displacement vector. Before that, we will see first this R1 vector, okay, R1 vector, which is also equal to OA vector with respect to the initial position A. So this can be written as x1, okay, x1 into I cap plus y1 into j cap, y1 into j cap. So I have written the position vector of the particle when it was initially at A at a time t1. So these are called the components, x components and y component of the position vector R1. Similarly, when the particle is shifted to a new position B at some other instant T2, the position vector is represented by R2. So this is represented by OB vector. So R2 vector is also equal to OB vector, and the coordinates are x2 and y2. Therefore, it is x2 into I cap plus y2 into j cap. And now this AB vector, okay, which is denoted by delta R, okay, delta R vector is also equal to AB vector. This AB vector only is called the displacement vector. So this only is called the displacement vector. We have to get an expression only for this delta R. Okay, we have already studied triangle law of vector addition, is it not? Look at the picture once again. You look at the triangle O A B. Okay, O A B. It is a triangle. Now R1 vector is represented between OA, that is from O to A. Then delta R vector is represented from A to B. And this OB vector, that is R2 vector, is represented from O to B. So these three vectors I am going to add. Okay, see here, R1 vector and delta R vector, they are following one another in the same order. They are in the same direction or same order, that is clockwise. R1 vector and delta R in the same order, whereas R2 vector is in the opposite order. It is in the anti-clockwise direction. So if I will add means this R1 vector plus delta R vector, okay, delta R vector, and this will be equal to the opposite vector, that is R2, that is R2. Therefore delta R vector is equal to what? R2 vector minus R1 vector, is it not? I will write here. Therefore this delta R vector is equal to R2 vector minus of R1 vector. So this is a R2 vector minus of R1 vector. Okay. So this delta R vector only is called the displacement vector. Now I am going to express this R2 vector and R1 vector in the component form, that is x1 y1 x2 y2 form. Already we have written expressions for R1 and R2 vector. I am going to substitute there. So this R2 is what? R2 is x2 into I cap, okay, x2 I cap, okay, plus y2 j cap minus of, okay, minus x1, okay, x1 I cap plus y1 j cap. I have just substituted for R2 vector and R1 vector. Then this I cap is a common factor. So this also can be written as x2 minus x1 into I cap plus y2 minus y1 into j cap. So this is left hand side is what? Displacement vector delta R. This also can be written as x2 minus x1 is what? The change in the x coordinate of the particle. So this can be written as delta x, okay, delta x into I cap plus y2 minus y1. y2 minus y1 is the change in the y coordinate of the particle. So this can be written as what? Delta y into j cap, okay, delta y into j cap. So this is the expression for the displacement vector. This is in vector form. Now I want to find only the magnitude. So magnitude of the displacement, okay, the magnitude of delta R vector, the magnitude of delta R vector is modulus of delta R vector, that is equal to delta R. So what is the magnitude of this displacement? That is equal to the distance. Anyhow, we want to find only the magnitude of this vector, so that this is now equal to square root of, okay, square root of delta x square plus delta y square, okay, plus delta y square. So inside the square root. Okay. Now this displacement vector delta R vector is equal to delta x into I cap plus delta y into j cap can also be represented by a diagram. Now I am going to represent that by a diagram. So in xy plane I am representing this delta x and delta y along the x and y axis respectively. So this is the y axis, this is the x axis. So that first we will take this AB vector, okay, this AB vector, that is the delta R vector, displacement vector. I am going to represent the displacement vector like this. So this is delta R. And the x component of this one delta x is the x component of the displacement. So the x component of the displacement is shown along the x axis, okay, shown along the x axis like this, okay. you have to draw like this. So this one, okay, this one is a delta x. Similarly, the y component is shown vertically, okay, this is shown vertically. So that this delta x along this, so this is O. So this is, we can use any symbol O, X, Y like this, so that along the x-axis, this is delta x, okay, delta x into I cap. And along the y-axis, it is delta y into j cap. And this angle is theta. Okay, theta is the angle made by the displacement vector with the x-axis. So from this now we can find the direction. So what is the direction of this delta r vector? Tan theta. Tan theta is equal to the magnitude of the opposite side is what? Delta y. And the magnitude of the x-axis, no, that is equal to delta x. And therefore theta is equal to tan inverse of delta y divided by delta x. So this theta gives, the value of theta gives the direction of the displacement vector with reference to the x-axis. So now I am going to explain this with an example. Are you ready? Okay. So this is an example with which we can easily understand how to find the magnitude and direction of the displacement vector. An object moves from a position 3, 4 to 5, 6 in the xy plane. Find the magnitude and direction of the displacement vector of the object. So here 3 and 4 are the x and y coordinates of the initial position, and 5, 6 are the x, y coordinates of the final position of the body. So I will take the first one is, okay, the first one is initial position vector, r1 vector. So r1 vector is equal to 3i cap plus 4j cap. So this is the position vector at the initial point, and the position vector at the final point r2 vector is equal to 5, 6. So this is 5i cap plus 6j cap. So if you want, you can write somewhere here as x1, y1. x1, y1 is equal to 3, 4. Similarly, x2, y2. So this is equal to 5, 6. These are the x and y coordinates. Okay. So r1 vector is equal to 3i plus 4j, and r2 vector is equal to 5i plus 6j. Now the displacement vector, okay, displacement vector first we will find out, which is denoted by, okay, the displacement vector is denoted by delta r, and this is equal to r2 vector minus r1 vector. So that this is now equal to 5i, okay. So I will write here. So delta r vector is equal to 5i, r2 vector is substituted here, 5i cap plus 6j cap minus of 3i cap plus 4j cap, okay, 4j cap. So that this is equal to 5 minus 3. So this is 5 minus 3 into I cap plus 6 minus 4. Okay, this 6 minus 4. So 6 minus 4 into j cap. So once again, delta r vector is now equal to 5 minus 3 is 2. So 2 I cap plus 6 minus 4 also is 2 j cap. Now magnitude, okay, magnitude of displacement, magnitude of the displacement vector, that is the modulus, okay, modulus. So delta r is equal to modulus of delta r vector, isn't it? So that this is equal to square root of square root of delta x square, okay, delta x square plus delta y the whole square. So this is equal to square root of 2 square plus 2 square. So what is the change along the x-axis is called delta x. Delta x is what? 5 minus 3, that is equal to 2. So delta x square is 2 square. Similarly, what is delta y? Change along the y-axis. Change along the y-axis is what? 6 minus 4, that is also 2. So this y square will become 2 square. So this is equal to square root of 2 into 2 square. So this is equal to 2 into square root of 2. That is equal to 2 into square root of 2 is 1.414. So this is equal to 2.828. So this is the magnitude. So whatever may be the unit of x and y, maybe in centimeter or meter. In SI system means it is in meter. Okay, so this is the magnitude 2.828. Now how to find the direction? The direction is given by what? Tan theta. So direction of the displacement vector delta r, that is tan theta. So tan theta is equal to delta y divided by delta x. So what is the delta y? Delta y is what? 6 minus 4, that is equal to 2, divided by delta x is what? 5 minus 3, that is also 2. So tan theta is equal to what? 1. Tan theta is equal to 1. Or theta is equal to, okay, or theta is equal to tan inverse of 1. Okay, tan inverse of 1 is 45 degrees. So theta is equal to 45 degree. So this is how we can determine the direction of the displacement vector. Okay students, fine.